using limits. Now, whenever we want to find the vertical asymptote, there is something that you need to know. So, to find the vertical asymptote, all that you need to do is, step number 1, I need to check if anything can cancel up or down first. If anything can cancel up and down, then you have to cancel it. Why? Because whatever cancels, this is called a removable discontinuity. We were able to remove it. Okay, this is like the whole. After the cancellation is done, all you need to do is solve the denominator equal to 0. The values that will make the denominator equal to 0 after the cancellation are where you have a vertical asymptote. So let's look at question number 23. I have x up and I have 4 minus x squared. If I were to factor the denominator down, I will have 2 minus x, 2 plus x. Sorry, here this is x. Can anything cancel up and down? Well, for sure no. So I go to the next step. What is my next step? Take the denominator and solve it equal to 0. So the denominator is 4 minus x squared. If I solve it to 0, how much will I get? I will get x equal to 2, x equal to minus 2. So what does this mean? This means that I have a vertical asymptote at these two values. Now, how did I find these answers, 2 and minus 2? Very simply using my calculator. Mod 5 is 3. A is negative 1. B is 0. C is 4. So I get 2, negative 2. Okay, now we are done with the vertical asymptote. Now we come, vertical asymptote. Now we come to horizontal asymptote. How can I find horizontal asymptote? In order to find horizontal asymptote, all you need to do is find the limit at infinity, find the limit at negative infinity. Now, whenever we have a polynomial over another polynomial, like in this case, in this question, x is a polynomial. 4 minus x squared is a polynomial. So there are no roots, there is no length, sine, cosine, it is just a polynomial. We have rules. If the degree of the numerator is more than the degree of the denominator, okay, if the degree up is higher than the degree down, then this means that there is no vertical asymptote. If the degree of the numerator is equal to the degree of the denominator, then you need to take the ratio of the leading coefficient. You need to take the ratio of the leading coefficient. If the degree of the denominator is more than the degree of the numerator, then the answer is directly 0. Now here I see that the degree up is 1, the degree down is 2. So the degree down in the denominator is more than the degree up in the numerator. So this means directly that there is a horizontal asymptote at y equals 0. Now, horizontal asymptotes can be done using the calculator. All you need to do is go and write your function same as it is. So here I will put alpha x 4 minus x squared. I will click calculate. Now, to find the horizontal asymptote, you need to find the limit of the function as it goes to infinity and negative infinity. So infinity means a big number. So for example, put 1 and then a lot of zeros, a very big number. And I click equal. Okay, so look what do I get. I get minus 1 times 10 to the power negative 9. What does this mean? Minus 1 times 10 to the power negative 9. This means minus 0 point and then put 9 zeros and then 1. So this number is approximately what? 0. So whenever you see a number, okay, 1 or minus 1 times 10 to the power of a negative number, so this means the answer is 0. Now again, if I click calculate, and instead of having this to be positive, I will put this to be negative. Again, what does this thing mean? 1 times 10 to the power negative 5, it means 0. So from both sides of the equation, I got 0. Okay, now looking at question number B, again, how can I find the vertical asymptotes? I will check if anything will cancel up and down. So again, I have up x squared. If I factor the one that's down, I will get 2 minus x, 2 plus x. Nothing cancels, so I go directly to the next step, which is solve the denominator equal to 0. Again, like we did in question A, we will get x equal to 2, x equal to negative 2. So what does this mean? This means that we have a vertical asymptote at these two values. Now to find the horizontal asymptote, I can compare the degrees. The degree up is 2, the degree down is 2. So whenever the degrees are equal, you need to take the ratio of the leading coefficients. The leading coefficient here is 1. The leading coefficient here is negative 1. So 1 over negative 1 is negative 1. So this means that there is a horizontal asymptote at y equal negative 1. Again, how could I have done this with the calculator? I will go to my calculator. I will write my function. And then I will click calculate, and then I will put a very large positive number. So I got negative 1. Again, I will click calculate, and I will put a very large negative number. So again, what did I get? Negative 1. So there's a horizontal asymptote when y is equal to negative 1. Now we come to question number 24, A and B. Here we see that we have roots. Again, step number 1, whenever that I am finding the vertical asymptote, I check anything can cancel up and down? No. So I take the denominator and I solve it equal to 0. So the root can go. This is like I squared both sides of the function. Now, whenever I try to solve this one, look what will happen. If I put this on my calculator, so mod 5, 3. A is 1, B is 0, C is 4. The calculator will give me answers that are imaginary. So what does this mean? This means that this is never going to be equal to 0. So if the denominator is never going to be equal to 0, this means that there is no vertical asymptotes. Okay. Now we go to the horizontal asymptote. Horizontal asymptote, I can do this with the calculator. I will go to my calculator. I will write the function. So here I will write x over square root 4 plus x square. Calculate. I will put a large positive number. I got 1. Then calculate. I will put a large negative number. I will get negative 1. So what does this mean? That there is a horizontal asymptote at 1 and there is a horizontal asymptote at negative 1. So we have two horizontal asymptotes. So a horizontal asymptote at y equal 1 and y equal negative 1. And that's it. This is the answer of this. Okay. If you are now wondering, so let me write this here so I have space to write. If you are wondering, how can I have done this solving? Okay, to solve this one, you cannot use these rules. Why? because this one says polynomial over polynomial. This is not polynomial over polynomial. The denominator has a root. So what you do is the following. You start by saying limit as x approaches infinity. X over 4 plus x squared. Now look, whenever we look under the root, we get rid of anything except the term that has the highest power. So here this is 4, this is x squared. I will get rid of the 4. What will stay? Will stay x squared. So now I have x root x squared. Now, the x squared can go outside the root. When it goes outside the root, it will go outside in absolute values. So square root and x squared, it's like the root and the 2, they cancel. But when it goes outside or it gets cancelled, it will be inside an absolute. Now, if the limit approaches positive infinity, I remove absolute x and put in its place positive x. If the limit approaches negative infinity, I remove the absolute x and I put negative x in its place. So here this one will become limit x approaches infinity, x over x. So I remove the absolute x and I put positive x in its place. X over x will become 1. So limit as x approaches infinity for 1 is just what? 1. Now what if limit is approaching negative infinity for x over absolute x? You will remove the absolute x and you will put in its place negative x. Why? Because x is approaching negative infinity. So x over negative x is minus 1. So now I have a horizontal asymptote at 1, horizontal asymptote at negative 1. Now we go to 24b. Again, for the vertical asymptote, do you see anything that cancels up and down? No. So what do? You take the denominator and you solve it equal to 0. So square root 4 minus x squared equals 0. The root will cancel. So 4 minus x squared equals 0. Now I need to solve this one. So I go to my calculator, multiply 3. A is negative 1, B is 0, C is 4. So I got 2, negative 2. So x equal to 2, x equal to negative 2. These are where the vertical asymptote is. Now we do the horizontal asymptote. When I do the horizontal asymptote, again, I need to check the limit as x approaches infinity, limit as x approaches negative infinity. Now notice here with me that 4 minus x squared, we get rid of anything except the term with the highest power. Here it is negative x squared. So I will end up with x over square root negative x squared. Now a square root cannot have a negative under it. So this means that this is not possible. So this means that this thing will not have a limit as x approaches infinity. So this means that there is no horizontal asymptote. How can I show this using the calculator? Put the function on your calculator. So put x over square root 4 minus x squared. Calculate and put a large number. See what did the calculator give me? It gave me an error. Why did it give me an error? Because this function is only continuous between 2 and minus 2. It cannot have values that are greater than this. So the calculator will give you an error. This is how you know that there is no horizontal asymptote. Okay, now I come to 25 and 26. 25 and 26 are polynomial over polynomial. So now I start by saying, does anything cancel up and down? Well, since this is a polynomial, I can try to factor it. So I will go to my calculator, mod 53. So I will factor the one that is up. A is 3, B is 0, C is 1. So calculator is giving me I. So what does this mean? It cannot be factored. So if this cannot be factored, then nothing will cancel up and down. So directly I will say vertical asymptote, and I will solve the denominator equal to 0. Okay, how do we solve this equal to 0? Again, we factor. So mod 5 is 3, 1, negative 2, negative 3. What do we get? 3 and minus 1. So x equals 3, x equal minus 1 is where we have a vertical asymptote. What about horizontal asymptote? Since this is a polynomial over a polynomial, we can use our rules directly, the ones that we saw here. If the degrees are equal, we take the ratio of the leading coefficients. So the degree up here is 2. The degree down is 2. The leading coefficient here is 3. The leading coefficient here is 1. So 3 over 1 is 1. So there is a horizontal asymptote. 3 over 1 is 3. So there is a horizontal asymptote at y equals 3. Again, if I want to check with my calculator, here's my calculator. I will write the function 3x squared plus 1 over x squared minus 2x minus 3. Calculate, put a big positive number. So look, we got 3.000006. If you want this to be more accurate, make the number bigger. So it's almost what? 3. Again, you want it even more accurate, keep adding zeros. So now it is exactly 3. What if I do shift calculate, but now from the negative? So a very large negative number. Again, the answer is 3. So we only have a horizontal asymptote when y is 3. Now we come to question 26. Again, I check. Anything can cancel up and down? Well, look here. 1 minus x cannot be factored more. X squared plus 2x minus 2. Let's factor this one. Mod 5 is 3. A is 1. B is 1. C is negative 2. So we got 1 and minus 2. So I say x minus 1, x plus 2. Whenever we factor, we flip the sign from the calculator. Now I notice that up I have 1 minus x, down I have x minus 1. They are almost the same, but I notice the signs are opposite. Here the x has a minus. Here the x is positive. Here the 1 is negative. Here the 1 is positive. So this means I can cancel them, but I need to put minus 1 when I cancel them. So now what do we end up with? Minus 1 over x plus 2. Now you check if there is a horizontal and if there's a vertical asymptote. So vertical asymptote we only check after the cancellation. So now where is this going to be 0? So here, where is the denominator going to be 0? When x plus 2 is 0. So x equal negative 2. And this is the only place where there is a vertical asymptote. If you were to skip the cancellation and say that there is a vertical asymptote at 1 and negative 2, you are incorrect. Why? Because the one that cancelled is a whole. It's a removable discontinuity. So which one cancelled from the denominator? This cancelled. So this one means that at x equal 1, if you go back and solve this equal to 0, you get x equal to 1. There is a removable discontinuity, not an asymptote. Okay, now we need to find the horizontal asymptote. Now we can go back to the degrees because this is polynomial over polynomial. Degree here is 1, degree here is 2. Denominator has a higher degree, so this means at 0 there is a horizontal asymptote. So horizontal asymptote at y equals 0. Let's check with the calculator. 1 minus x over x squared plus x minus 2. Calculate. Put a large number. So now look, whenever you get a number 10 power negative a number, this means 0. Again calculate. Put a very negative large number. So what do we get? We also got 0. So there's a horizontal asymptote when y is 0.